We are going to start Unit 12, which is the last unit of the year. Yay! Unit 12 is about circles. So, first thing we need to do is get some vocabulary down. You know you love it. You know you want to learn it. Vocab! Woo woo! All right. So, the circle of life. Yeah, that was beautiful, wasn't it? All right. Circle. So a circle is just a whole bunch of points that are the same distance away from a point called the center. So here is the center of my circle right there. We'll cleverly call it C for center. And every single point on this circle is the same distance away from point C. So if you stuck a push pin in point C and then tied a string to a piece of chalk or something and held the string out tight and then went around in a circle, it would draw a circle. That's the definition of the word circle. So, that's the center right there. And the distance from the center to every point on there is called the radius. Yay. All right, you guys all knew that. So there are some other words that you may not know, and you need to know how to name them correctly. So the first one you need to know is chord, spelled like a musical chord. C-H-O-R-D, chord. So a chord is just any segment that you draw that has both endpoints somewhere on the circle. So it's a line segment, both endpoints are on the circle. So since it's a line segment, you name it with the segment bar on top, and the two endpoints are the two letters. So segment AB is a chord. Now, if the chord happens to go through the center of the circle, like this one, that segment is still a chord, segment MN, it's still a chord, but it's a special kind of chord. We call it a diameter. If it goes through the center of the circle, it's a diameter. And of course, half of the diameter is called the radius, still a line segment. So notice all of these are named with the segment bar on top. And if you leave that segment bar off, or if you put a line symbol on top, you're going to get it wrong. Make sure you're naming it with a segment bar. If it asks you for the center, it's a point. Just name it with a capital letter. C would be the center of the circle here. Now, chords are just line segments. They stop on the circle. If it's a line, if it continues and it crosses the circle twice, it's called a secant. So this line is a secant, line EF. So notice that I have named it with the double arrow symbol on top, line EF. Now, if I were only talking about this part of the line, between E and F, that would be a chord, but the whole line is a secant. Now, if you have a line that only touches the circle just once, it's called a tangent. Just like the tangent we talked about with trigonometry, it's spelled the same word, totally different meaning. It's called a tangent. If you've ever heard the saying, go off on a tangent, that's what you guys always want your teachers to do. Oh, we're going to get Ms. Linford distracted so that she is talking about the topic, but then she totally goes off on a tangent and ends up a million miles away from what she was supposed to be talking about. So that's where that phrase comes from. So a tangent touches the circle at just one point. The point where it touches is called the point of tangency. So a tangent can either be named like a secant with 2 points on the line and a double arrow, or remember, lines can be named with a lowercase cursive letter. So this could be named line L, or if I had another point down here, maybe it could be named line GH with a double arrow. And the point of tangency here is G. Now, sometimes we're only interested in a part of that tangent line, specifically a part that goes from the point of tangency to another point. That's called a tangent segment. Here's a drawing that kind of summarizes this. It has one other word on it, but tangent touches just once. A line. Secant, a line that touches twice, cuts the circle twice. Chord is a segment that touches at both endpoints. A diameter is a chord that goes through the center. Radius goes from the center to the circle. And a term we'll talk about a little later on is an arc, and that is just part of the circle. So the first types of problems you're going to be doing, you will be given a diagram and you will be asked to give the right vocabulary term. So the first term the first piece we're asked to look at is segment AF. So that's that segment right there. Well, it's got both endpoints on the circle, but it goes through the center of the circle. So that is a diameter. That's the most specific name for it. It's also a chord. But if it wants the most specific name for it, it's a diameter. All right, segment EG. All right, it's a segment. It has both endpoints on the circle. Segment with both endpoints on the circle. That is a chord. Okay, segment PF. So from P to F, that is from the center to a point on the circle. That is a radius. Segment PG. Again, center to a point on the circle. Well, that's another radius. Point C. We only talked about two types of points. We talked about the center. Well, the center is right here, point P. So we'll go ahead and fill that in. And the other type of point we talked about was a point where a tangent line touches a circle. You can see that point C right there is where this line, which is a tangent, touches the circle. And that's the only place that that line touches the circle. That's called a point of tangency. So if it asks you about a point, it's either going to be a center or a point of tangency. Those are the only 2 points we talked about. Now, both of these have the double arrows at the end. It might be hard to see if you're looking at a little tiny screen. The computer has a hard time making those double arrow symbols. But that is line CE. So that wants me to talk about this whole line. Now, if it just said segment CE, if it just wanted the part of the line from C to E, if it said segment CE, that would be a diameter because it goes through the center. But line CE is a line and it crosses the circle at two different places. A line that cuts the circle at two places is a secant. And the last one is line BD. So we mentioned that a minute ago. It's a line and it only touches the circle at one place. That's called a tangent. All right, the next type of problem is very similar, but this time it's going to give you the vocabulary and it wants you to write the symbol of the point, line, or segment. Now, it's very important that you use the right type of symbol. If it's a segment, we want to see the segment bar, like this. If it's a line, we want to see a line symbol with a double arrow. If it's a point, capital letter. They should all have capital letters. Okay, a chord. So a chord is a segment that touches the circle at its endpoints. You actually have three choices of that. The most obvious one, this is a chord and only a chord. It's nothing else, would be segment KM. It has to have the segment bar to be correct. But there are two other chords. This is a chord, it's a segment, and both of its endpoints are on the circle. Segment PK or KP. The thing is that is also a diameter, because it's a chord that goes through the center. So I'll fill that in right now. And if we only look at this part of that line down there, not the whole line, just the part between P and M. So just the segment part of P and M. Segment PM, not line PM, that is a chord. If you look at the whole line, it's not, but just the segment, it is. Okay, radii, R-A-D-I-I, that is the plural form of radius. Like cacti means more than one cactus, radii means more than one radius. So this wants me to find 2 radii. So I want to find 2 of those. So from the center to a point on the circle, there's one of them. Segment QK. And here's another one. Segment QP. And remember, when you're naming segments, it doesn't matter which letter goes first. I could have named those segment KQ and segment PQ. It doesn't matter which letter goes first, but you do have to have the segment bar on top. Okay, tangents. Tangents are lines. I need to write double arrows on top that touch the circle at just one point. And it says there are 2 of them. Well, here's one right here. That touches the circle right there. So I need 2 points on that line to name it. That goes through point N and point M. So I can name that line NM. Got to put the double arrow symbol on it. And its point of tangency is where it touches the circle. It touches the circle right there at point M. The other tangent is this line right here. It goes through points P and N. So I can name it line PN or line NP, doesn't matter as long as you have the double arrow on top. And it touches the circle at point P. So that is my other point of tangency, is point P right there. Okay, the last thing I am asked for that I haven't written down is a secant. So a secant is a line that crosses a circle at two places. So I have one of those right here. This line crosses the circle at two places. Now I need to make clear it's a line, so I've got to use the double arrow symbol, and it crosses through points P and M. So notice segment PM, just this part, is a chord. The whole thing is a secant. So chord right there, the whole thing is a secant. So be clear about whether you're talking about the segment or the line. Now we're going to shift to talking about angles inside circles and arcs. So an arc is just a piece of a circle. That's just part of the curve of the circle. And we have two kinds of arcs. We have a minor arc. Less than half of a circle is a minor arc. So less than half of circle. That's a minor arc. Major arc is more than half of a circle. Okay, if you draw an angle that goes from the ends of the arc and has a vertex at the center of the circle, so its vertex is the center of the circle, and its sides are radii. Each side is a radius, and its center is the center of the circle. That's called a central angle. Now, the measure of a minor arc, this arc measure right here, is equal to the measure of that angle right there. Now we name minor arcs like this. We name them with two letters, the two end points, with a little curve on top. So that minor arc is arc AB. We name major arcs with three letters. You start at one end point. I'm starting at A, and then you name a point that you go past, and then you name the point you end up at. So this is arc ADB. Or you could name it arc BDA. So it's a point, it's an end point a point you go past, and the point you end up at. They have to be in order, kind of trace the arc as you go. So 2 letters is a minor arc, 3 letters is a major arc. Okay, so the measure of the minor arc is just how big is that central angle. And if you've ever watched snowboarding or skateboarding, or you're into those extreme sports, you should know that if you do a complete flip, a complete circle, there are 360 degrees in a circle. So if we figured out how far it was from here to here, and we want to figure out how far around the rest of it is, what we do is we take 360 and we subtract that angle measure. And so the measure of the minor arc is the measure of that central angle. The measure of the major arc is 360 minus the central angle. So let's look at an example here. So we're going to find the measures of the angles and arcs and the names of the angles and arcs. So on this one, the measure of the central angle, well, it gives that to me right there. Measure of the central angle is 100 degrees. And the name of that central angle, we will name it with 3 letters. That is angle BAD. Bad angle. I like giving angles interesting names. All right. Now I want to name the minor arc. I'm going to leave that one traced in blue, so I've got this color coded. Okay, the minor arc well, that has the same measure as the central angle does. If the central angle has a measure of 100 degrees, so does the minor arc. And the name of the minor arc, just name it with 2 letters, either BD or DB, with a little curve on top. And make sure I can tell it's curved and not flat. It is an arc, it's not a line segment. Okay, now the major arc, well, there are 360 degrees in a circle, and I've used up 100 of them. So 360 minus 100 is 260 degrees. So if we spin around the rest of the way, that would be 260 degrees. And the name of that arc, we need to name it with 3 letters. I covered up the letters so you couldn't read it. Let's make it a little more readable. So I can name that with 3 letters. Pick which one to start with. If I start with B, I start at B, I go past C, and I end at D. So B, C, D. Or D, C, B. So the major arc has 3 letters, the minor arc has 2 letters. There's a special name if you have an arc that measures exactly 180 degrees. It's called a semicircle for half a circle. So this one would be arc PQR. I can't write an R apparently. It's a very difficult letter to write. Is a semicircle. So here's a couple more like the one we just did a minute ago. naming the central angle, giving its measure, naming the minor arc, giving its measure, naming the major arc, giving its measure. So I will do these very quickly. So my central angle right here is angle QPS. Don't leave off the angle sign. Its measure is 45 degrees. Our minor arc is arc QS, and its measure is equal to that arc, or that angle, so it is also 45 degrees. And our major arc, going all the way around here, is arc QRS, or SRQ. And to get its measure, 360 minus 45 degrees is 315 degrees. Central angle on this one. Y. Angle WHY. Well, it's got a right angle mark in there. That means its measure is 90 degrees. Minor arc right here would be arc WY or YW, and its measure is also 90 degrees. Major arc would be the rest of the circle. Arc WXY or YXW. And 360 minus 90 is 270 degrees. Now you may see some where you have a bunch of angles and arcs on the same diagram that it wants you to figure out. So one thing that you want to look at is it tells you that you have some diameters. Those are cutting the circle in half. It's telling you that you have some things that add to 180. And also look for vertical angles. So I can see right here I have an X. Remember that the angles across from each other are vertical angles. They're congruent. So this one's 35 degrees also. Okay, so I've got my vertical angles there. And you want to look for things that add to 180. So if this is a diameter, then those two angles add to 180. So 180 minus 35 is 145 degrees. And the other three angles also have to add to 180. So let's do 35 plus 92. That's 127. And 180 minus 127 is 53 degrees. All right, so I have all my angles filled in. Now I'm going to go ahead and look at the arc measures. So arc DC. Well, from there to there, I look at the central angle. 35 degrees. Arc BC. Well, that's that one. its central angle is 145 degrees. All right, CDE. So I start at C, I go past D, and I end at E. So I have two angles to add together there. So 35 degrees plus 53 degrees equals 88 degrees. All right. Measure of arc DE. Okay. That's that one. Have that one in green. That's 53 degrees. Okay, this is a big arc. Arc ABE. So I start at A, I go past B, and I end at E. You've got a couple of choices there. You can either add all of those together, or you can say, well, the whole circle is 360, and I have everything circled except the 92. Probably the fastest way of doing that is saying, well, that's the major arc that goes along with the 92 degrees. That's everything except 92 degrees. 360 minus 92 degrees is 268 degrees. That's the rest of the circle. Okay, ABD. Again, you have a choice. You can add those three. You could notice that, hey, I've got 180 right there plus 35. It's up to you. So you can do 35 plus 145 plus 35. And that's 180. So that's 215 degrees. So it takes a little bit of thinking. You have to figure out what you know about a circle, and you have to use what you know about angles and do some thinking on that type of problem. All right, there are a few other things you need to know, and they involve what we call inscribed angles. So an inscribed angle is a little bit different from a central angle. We were just talking about central angles. So a central angle had a vertex in the center of a circle. Central angle, the vertex was at the center, and the two sides were radii. An inscribed angle is a little bit different. An inscribed angle, the vertex isn't at the center, the vertex is on the circle. And the two sides aren't radii, the two sides are chords, or they have chords of the circle. That part is a chord. And then it has a little bit more. So the two sides have chords of the circle as part of the side. So what we want to think about is, well, we know that the measure of that arc right there is equal to the measure of the central angle. How is the measure of the arc related to the measure of the inscribed angle? So on this diagram right here, I have a circle, and this circle has both a central angle and an inscribed angle, and both of these intercept the same arc. Arc BA is the arc that is intercepted by both of these angles. And what we want to look at is what's the relationship between these. So if you look at this, the central angle has a measure of 80 degrees, and that is also the measure of arc AB. Arc AB has a measure of 80 degrees also. Well, the inscribed angle has a measure of 40 degrees. 80 degrees, 40 degrees. Seems like there's a relationship there. And I can go ahead and I can move this around, and you can see that this is also an inscribed angle, and it still has the same central angle. The central angle always goes from the two end points of the inscribed angle. There's the end point, there's the end point, and connects them to the center. And so you can see that this still has a measure of 40 degrees, and this arc still has a measure of 80 degrees. So all of these inscribed angles, every single angle here that has a central angle of angle BOA, the inscribed angle has a measure here of 40 degrees, and the central angle has a measure of 80 degrees, and the arc has a measure of 80 degrees. Now I could change the measure of the central angle. Look, now the central angle has a measure of 100 degrees, and look what happened to the measure of the inscribed angle. The measure of the inscribed angle now has a measure of 50 degrees. And no matter where I put the inscribed angle, it still has a measure of 50 degrees. And remember that this number right here, that 100 degrees, is also the measure of arc BA. So this inscribed angle, hey, that seems to be half of that, which means this is also half of the arc measure. Or if I know this, the arc measure, or this measure, is 2 times the inscribed angle measure. So we have this theorem that says the measure of an inscribed angle, so angle ADB is an inscribed angle, its measure is half of the measure of the arc right here. So the measure of this angle, the inscribed angle, is half of the arc measure. Or you can flip it around and say the measure of the arc is 2 times the measure of the angle. So here's an example of how that works. The inscribed angle, that's the blue one right here, angle ADB, its measure is 60 degrees. That is half of the arc measure. Arc AB has a measure of 120 degrees. So this 60 degrees is half of that 120 degrees. Or this 120 degrees is 2 times that 60 degrees. Now I also drew the central angle on here. I drew the central angle, angle ACB, to remind you that the arc measure is equal to the central angle measure. So here's a summary right here. The arc measure equals the central angle measure. the measure of arc AB equals the measure of angle ACB. But the arc measure is 2 times the inscribed angle measure. So the measure of arc AB, 120, is 2 times the measure of angle ADB, 60. Or flip it around. The inscribed angle measure, angle ADB, the 60, is half of the arc measure, 120. So when you look at a problem, you need to always ask yourself, is the angle I'm looking at inscribed, or is it a central angle? Because that will tell you whether you have something equal to the arc, or whether you have something that is half of the arc. And so you've always got to keep track of, am I looking at an inscribed angle, or am I looking at a central angle? So these 3 are all inscribed angles. And it's asking me to find either the intercepted arc measure, or it's giving me the arc measure and asking me for the angle. So this is an inscribed angle right here, and it wants me to find the measure of this arc. So arc measure is 2 times the inscribed angle measure. Multiply by 2. The measure of arc DF is 144 degrees. Okay, well, now I'm going the other direction. I know the arc and I want the angle. So, if I want the angle, an inscribed angle, I divide by 2. 42 degrees divided by 2 gives me 21 degrees. So the measure of angle JKL equals 21 degrees. Okay, I have the angle, I want the arc. Multiply by 2. Notice that's more than half of the circle, so this better be more than 180. 112 times 2 is 224 degrees. Measure of angle of arc, XWZ, equals 224 degrees. So, if you know the angle and you want the arc, multiply by 2. If you know the arc and you want the angle, divide by 2. But that is only if it is inscribed. If it's a central angle, they're equal. This is only if it's inscribed.